Hi, good morning, everybody. This is Tapu Strategy this side. Today, we'll continue our discussion with the chapter pressure. Last day, in the last two videos, we discussed about basic conception of pressure and its definition, its unit and dimensional formula, whether pressure is a scalar or vector quantities, and also we did some few numericals on basic concept to clear the basic concept of pressure. Okay, and today we'll discuss, we'll mainly discuss different properties of fluid pressure. Properties of fluid pressure. Fluid pressure. Different properties of fluid pressure. And we all already mentioned that fluid here we consider which is at rest according to our scope. And here mainly we concentrate our discussion on liquid. Okay, we imagine uh, properties of liquid. Okay, and let us begin with our regular day life experience, day life activities, uh, from where we uh, notice some basic properties of pressure. Okay, let me share some demonstration. Here, we consider here we consider let me take a color. Okay, here we consider a container, cylindrical container, and there is a hole at that depth. Okay, initially this was closed. That is, these holes were closed. First, fill the container with water or any other liquid. Then simultaneously open these three holes. What will happen? What will notice? That is that you can see in the screen. That is, from the bottommost hole, the water reaches at the maximum distance from the position of the container. Here, from the middle one, the water reaches here, and from the uppermost hole, the water reaches at the nearest point with respect to the position of the container. So what we find here, as the depth increases, here the thrust increases. As the area of the each holes are same, so pressure, as thrust increases, so pressure also at the bottommost. Suppose I consider this is P1 and this is P2, this is P3. So what we find, P1 is greater than P2 is greater than P3. How we can say this? As depth increases, the thrust also increases. Okay, and as pressure is equal to thrust per unit area, and area is same for all these cases, as thrust increases, pressure also increases. So from the bottommost hole, the water reaches at the maximum distance. Is that clear? So from here we find that with the depth pressure of a liquid increases. Okay, and this can you can generalize in case of fluid also, that is in case of gas also we find the same properties. Is that clear? Another phenomenon, next we'll discuss with another phenomenon. Okay, let me share the image. Here we consider a container. Here we consider a container. This is filled with some liquid or water. Okay, this is a simple arrangement. Here a rubber tube. This is rubber pipe, and is front part is attached with a funnel, and here it is a balancing bubble. Okay, so as pressure increases, this pressure changes, this bubble shifts horizontally, and from the scale attached here we can find out how much it increases or decreases. As pressure increases, this bubble moves rightward. As pressure decreases, the bubble moves leftward. Okay, when as pressure decreases, the bubble moves leftward, and the pressure increases, the bubble moves rightward. Okay, now at the different positions of the liquid, I just moves the funnel. When I just put the funnel initially at this position, then at this position, then at this position, what we find, the position of this position of this pointer, bubble pointer, remains same. Okay, this observation we will get. So from these, what we can conclude from here, from this observation, we can conclude that at a same horizontal point, the pressure at any direction is same. The pressure exerted by the fluid at any direction at a particular point is same. That is, if we consider particularly this point, let me take another color. I don't know whether it is seen or not. So here at this position, if we consider the pressure towards this direction, towards this direction, this direction, this direction is same. Clear? It is not changing. And what we find, that if we uh, put this funnel uh, at a depth, at a greater depth, then the pointer, bubble pointer will move down rightward. If we move this funnel upward, the bubble pointer moves leftward. Clear? So from here, what we again conclude, that with depth, the pressure of fluid increases. Is that clear? So this is a few general demonstration from our regular day-to-day life, from where we can understand the pressure changes with the depth. The pressure is same at a same horizontal level. And now in the following video, we'll theoretically prove that pressure increases with depth, and pressure depends on few other physical quantities that will that we'll do in the next following video. Okay, thank you.